Ready to do some Chapter 8 extra practice. Let's get to it. Example number 1 says find the critical value for a right-tailed z-test if alpha is equal to 0.04. Use notation around to 2 decimal places. Alright, since it's a z, I have a normal distribution, standard normal. I'm using the right tail. And alpha, that's the area in the tail or tails combined, is 0.04. And the z-score is the critical value that I need. Alright, if the right tail has 0.04, then the left tail is going to have 0.96 in it. I get that from 1 minus 0.04. Let me clear off my calculator real quick. In second vars, number 3, inverse norm, I type in 0.96. 0 is the mean, standard deviation is 1 since it's standard normal, and I get my answer. Rounded to 2 places, I get 1.75. Number 2, find the critical z-scores for a hypothesis test if alpha is 0.09 and h sub 1 reads that mu is not equal to 49.8. Again, this is a standard normal distribution because it's z-scores, and there will be 2. The not equal to means this is a two-tailed test. In both tails combined, I'll have 0.09, so I have 0.09 divided by 2 in each tail. I can use the calculator to help me find that. Alright, 0.045 will be in each tail. And I need both z-scores, the left and the right. Let's find the one on the left first. Alright, to do that I'm going to use inverse norm, 0.045, 0.1. Rounded to 2 places, I get negative 1.70. Alright, you might be able to guess what the one on the right hand side is going to be, but let's do it anyway. For that one, I do inverse norm, 1 minus 0.045, 0 and 1. And what do you know? I get a positive 1.70. Those two answers combined make my final overall answer. There they are. Next is example number 3. It says find the critical value for a hypothesis test if alpha equals 0.08 and h sub 1 is that p is less than 0.2584. Alright, since there's a lowercase p in the hypothesis, this is for a one-prop z-test. So again, I'm going to be in a standard normal distribution. Since there's a less than in h sub 1, this is left-tailed. And 0.08 is the amount in that left tail. Next step, use my calculator, inverse norm, area to the left, 0.08, 0 and 1. And I get my answer, negative 1.41. That's number 3. All right, now for number 4. 4 says find the critical value for a t-test. Oh, so now we're in a t-distribution. If alpha is 0.01, n is 21, and h sub 1 is that mu is greater than 1.485. So number 4, again, I'm in a t-distribution. It's going to be a little flatter. Drawing's not the greatest, but okay. Notice in h sub 1, I've got a greater than, so it's on the right tail. That's the t-score I need. The area in that tail is going to be alpha, 0.01. Now let's talk about the sample size. N is 21. Since it's a t-distribution, I need the degrees of freedom, which is n minus 1. That's going to be 21 minus 1, which is 20. The next step is to use the table. On my formula sheets and tables packet, I scroll down to table A3. That's the t-distribution critical t-values. I have one tail, so the area in one tail is 0.01, and I match that column up with a degrees of freedom of 20. I didn't draw it just far enough. Here we go. And I get the answer of 2.528. That is the answer. Since it's on the right side, I don't have to add a negative. Now number 5. It says find the critical value for a left-tailed t-test if alpha is 10% and n is 17. So now I've got my t-distribution again. Left-hand side has 0.10. N is 17. So the degrees of freedom are going to be 16. Now back to the table. Since it's a t value, area in one tail is 10%. Match that up with 16 degrees of freedom, and I get a 1.337. However, notice that this is the left tail. The table only gives me the right tail, so I need to put a negative on it. So negative 1.337. Number 6. Find the critical t-scores for a hypothesis test if alpha equals 0.2, n is 6, and h sub 1 is mu is not equal to 515. This time I'll find 2 t-scores. Alpha is 20, so half of that will be in each tail. N is 6, so the degrees of freedom are going to be 5. We'll need both the left and right tail to complete the answer. All right, I go to my tables. Area in one tail or area in two tails. Doesn't matter which one you use in this case. I'm going to use the rightmost column. And degrees of freedom is 5. And I get a 1.476. That's the one on the right-hand side. Can you guess the one on the left-hand side? Yeah, that's right. Negative 1.476 is the one on the left. If you're filling those in on the homework, sometimes you have to put a comma between them for it to understand that you have both. Now for number 7. 7 says, what's the definition of the p-value that you find when you perform a hypothesis test? All right, the p-value, uppercase P is the symbol. It is the probability of the sample data occurring the way that it did. Under the assumption that H sub 0 is true. So what you're doing in hypothesis testing is you assume that the null hypothesis is true, and you find the probability of your sample data shaking out the way it did, if that's the case. And if it's low enough, if it's rare enough, you use the rare event rule to say that that's probably not true. All right, number 8 says find the p-value for a left-tailed hypothesis test with the test statistic z equals negative 2.23. All right, it's a z, so it's in a standard normal distribution, left-tailed. So we're looking at the left side. Test statistics negative 2.23, and we need to find the p-value. What that means is that we need to find the area to the left of our test statistic. Okay, to do that, we go back to normal CDF, start at some insanely large negative number, 10,000 or more is fine. Go up to your test statistic, put in a 0 and a 1. Now, if this had asked for the for a right-tailed hypothesis test, I would have found the area to the right. Since it's to the left, it's left-tailed. That command is in second bars, number 2. Negative 2.23. Be sure to use the negative, not the minus button, and you get your answer. Let's see here. Let's round this, since it is a p-value, to 4 places. So we get p is approximately 0.0129. The next part of the problem says compare the p-value to alpha at 10%. So let's say alpha is 0.10. And you can put extra zeros on there if it helps you. Then either reject or fail to reject the null. Well, in our case, alpha is bigger, so we reject H sub 0, or the null hypothesis. That's number 8. Now for number 9. Number 9 says find the p-value for a hypothesis test with the test statistic z equals 1.36, and h sub 1 is mu is not equal to 8547. So here's my distribution. Test statistic is going to be about right here, 1.36. Now notice this is a two-tailed test because of the not equals to in h sub 1. So I'm looking for either tail. Okay, I'm looking for the area to, well, we have to think about it for a minute. 1.36 is on the right-hand side of the distribution, right? Zero's in the middle, and it's positive, so it's on the right-hand side. So you will want to find the area to the right. If this had been a negative number, we would have found the area to the left. So go to the tail that's closest. In this case, 1.36, go to the right. We'll do that with normal CDF. 1.36, some insanely large number. Run out of room over here. A 0 and a 1. Second bar is number 2. do, we get the answer. Here's the p-value. The p-value is approximately 0.0869. Let's compare that to alpha. The alpha in the problem is 5%. So alpha equals 0.05. Put some more zeros on there. This time p is bigger. When p is bigger, we fail to reject the null hypothesis h sub 0. Okay, let's do number 10. Brain volumes of unrelated subjects used in a study are listed below. Use a 0.05 significance level to test the claim that the population of brain volumes has a mean less than 1100 cubic centimeters. And I have a list of numbers. First thing you've got to do with that list of numbers, go to Stat and Enter, clear off any old list that you still have there, and put that list, remember it's one sample, so one list, into list 1. Once they're typed in, let's see here. This is going to be for a mean. All right, so I know it's either a z-test or a t-test. How about the standard deviation? Well, none is mentioned, so the standard deviation will have to come from my list of numbers. All right, let's do this. First step, identify the test. We'll call it step A. This is going to be a t-test. Now we'll set up the hypotheses. H sub 0, H sub 1. Mu equals and mu. The number I'm asking about is 1100. And it mentions less than. So less than is there. And that is the claim. I know that because it says test the claim that. Next part, use the calculator. To get out of my list, I press second mode, then stat, test. Number 2 is t-test. Select data. Mu sub 0 is the number from our problem. Uh-oh. Just a second on that. Alright, mu sub 0 is 1100. Having some technical difficulties today. There we go. Your list is L1. Be sure it says that. Frequency is 1. And make sure that your tail is matched up, less than, and I'm ready to calculate. Once it does its thinking, I get the p-value of 0.7814. Next step, decide. Compare that to alpha. Alpha is 5% in this problem. P is bigger. When P is bigger, we fail to reject the null hypothesis. Next thing to do is to interpret. All right, in this case, since we failed to reject, there's not enough evidence. All right, the claim is H sub 1, so support. To support the claim that, now we have to relate it back to the original problem, the population of brain volumes has a mean less than 1100 cubic centimeters. That's number 10. Number 11 says, a community service organization claims that 3/4 of all adults believe it is important to be involved in their communities. In a survey of 1,021 randomly selected adults, 89% believe it is important to be involved in their communities. So test the community service organization's claim. Alpha is 10%. Number 11, first step, this is for a proportion, because it talks about 3/4. That's a proportion. So this is a 1 prop z-test. The lowercase p equals and lowercase p for the hypotheses. The number that I'm curious about here that's being claimed is the 3/4. Let's change 3/4 to a decimal. It's already in a fraction. Alright, so just in case you need it, 3/4 is 0.75. That's the number. Alright, the claim is that it is 3/4. So h sub 0 is the claim. There's no inequality mentioned, so we'll just test not equal to, two tails. That leads us to the calculator. Stat test and number 5. P sub 0 is 0.75. X, oh, we don't have a number for X. The problem says that out of 1,021, 89%. Okay, so let's go back. Second in mode. Let's find 89% of 1,021. You do that by multiplying 0.89 times 1,021. And when you get the answer, just round it like you normally would round. So this is actually 909. You have to round it to the nearest whole number. And n, of course, is 1,021. Now let's go back. Stat test number 5. 909, 1021, and not equal to. When we hit calculate, we get an answer. Alright, so P value is 4.12 and so on. Then there's this E negative 25. That means times 10 to the negative 25th power. So move the decimal over 25 places. You get 0.00000000 and so on, until eventually you get to 412 and so on. Alright, we're only rounding to 4 places, so it looks like it's going to be a bunch of zeros. 0.0000. Now it's not exactly zero chance, alright, it's a positive chance, but it is so close to zero that we're just, when we round to 4 places, that's all we show. Next step, compare it. Alpha is 10%, and you can see that alpha is definitely bigger, so we reject h sub 0. Alright, now for the conclusion, there's enough evidence, or there's sufficient evidence to reject the claim, since the claim's h sub 0, that 3/4 of all adults believe It is important to be involved in their communities. There's the entire problem again. That's number 11. Number 12. A sample of 32 male college students has a mean weight of 83.7 kilograms. Test the claim that male college students have a mean weight greater than the 83 kilogram mean weight of males in the general population. Okay. Use a 0.01 significance level and assume that the standard deviation of all male college students' weights is known to be 10.5 kilograms. So number 12, we're doing means. So it's either going to be a z-test or a t-test. Do we have the standard deviation from the population? Yeah, standard deviation of all tells us that this is going to be a z-test. Let's set up the hypotheses. The population mean that we're testing or curious about is the 83 kilograms. So 83 is the number. We're seeing if the sample shows that the college students have a mean greater. And that is the claim. We have stats, so be sure to highlight that. Mu sub 0 is 83. Standard deviations, or standard deviation is 10.5. X bar sample means 83.7. That's the sample mean of those 32 students. N is 32. Greater than's the symbol. And we calculate. P-value is going to be 0.3530. Alpha is a 1% significance level. Move my calculator. P is bigger. When P is bigger, we fail to reject H sub 0. Now let's write the conclusion, put it back into context. We failed to reject, so there's not enough evidence to support, because H sub 1 is the claim, to support the claim that, now put it back into terms of the problem, male college students have a mean weight greater than 83 kilograms. There's number 12. Let's do 13. A sample of 106 body temperatures has a mean of 98.4 and a standard deviation of 1.43. Use a 5% significance level to test the claim that the mean body temperatures of the population is different than 98.6. All right, number 13. First, the type of test. It does mention a mean, so it's a z or a t. We have a standard deviation, but notice that it is from this sample. Since it's from a sample, this is a t-test. The number that we're curious about is the 98.6. And there's no inequality mentioned, so not equal to. The claim is that it's different. Okay, if you have a number different than 98.6, it's not equal. So let's label that and move on. We have stats this time. Make sure it's labeled. Mu sub 0 is 98.6. X bar is the 98.4. Standard deviation 1.43. 106 people total. All right, when I calculate, here's what I get. P-value is 0.1529. Compare that to alpha, which is 5%, 0.05. Put some more zeros on there. P is bigger, so we fail to reject the null. For part E, let's relate this to the problem. We failed to reject, so there's not enough evidence. To H sub 1 is a claim, so to support There we are. There's not enough evidence to support the claim that the mean body temperature of the population is different than 98.6 degrees Fahrenheit. Number 13. On to 14. It says a poll of 1,000 randomly selected adults showed that 460 of them feel public speaking is the activity that they dread most. Uses information tests the claim that fewer than half of adults would say that public speaking is the activity they dread most. Use a 1% significance level. Number 14 is talking about less than half. Half is a proportion. So this is a 1 prop Z test. We're talking about less than half. Test the claim that fewer than half. Half is going to be 0.5. And the claim is H sub 1. X is the 460 people. N is 1,000. There's the calculator input. gives us a p-value of 0.0057. Next step, alpha is 1%. Alpha is still bigger, so we reject h sub 0. For the interpretation, there's enough evidence, or there's sufficient evidence to support the claim that fewer than half there's the rest of it. There's enough evidence to support the claim that fewer than half of adults say that public speaking is the activity they dread most. One more hypothesis test, number 15. The weights and pounds of discarded plastic from a sample of households have the summary statistics n equals 62, x bar equals 1.911 pounds. If the population standard deviation is known to be 0.418 pounds, test the claim that the mean weight of discarded plastic from all households is greater than 1.8 pounds. Use an alpha equal to 10%, or 0.1. This is for a mean, because it mentions the word mean under the second bullet point. And also in the sentence I highlighted mentions the population standard deviation. So this is a Z test. The number in question is 1.8. Greater than is mentioned, and that's the claim. Make sure stats is highlighted. All right, sigma is the 0.418. X bar is denoted as such in the problem. N is also there. Make sure it says greater than. Here's my calculator input. And the p-value is going to be 0.0183. So we're done with the calculator. Alpha is 10%. So alpha is bigger, and we reject the null hypothesis, h sub 0. Now to interpret. Since we rejected, there's enough evidence. Since h sub 1 is the claim, we use the word support. Here we go. Conclusion: there's enough evidence to support the claim that the mean weight of discarded plastic from all households is greater than 1.8 pounds.